Ever wondered why some problems in programming seem so daunting? Well, you're not alone. Programming, at its core, is about problem solving. It's about taking complex, real-world problems and breaking them down into manageable parts that a computer can understand and execute. But why does it often feel like a Herculean task? That's because programming problems are often abstract and multifaceted, requiring a blend of logic, creativity, and technical knowledge. Programmers frequently face challenges such as understanding the problem, choosing the right tools, and implementing the solution. These obstacles can make the overall process seem overwhelming. But here's the good news: these skills can be learned and honed. Just like learning a new language, problem solving in programming takes practice, patience, and a lot of trial and error. In the next few minutes, unravel the secret to effective problem solving in programming. First off, identifying the problem is crucial. It's like knowing your enemy before going into battle. Imagine you're a detective. Your mission: to solve a mystery. But before you can even begin, you need to know what the mystery is, right? The same principle applies in programming. Before you can solve a problem, you must first understand what the problem is. Sounds simple, but it's a step that's often overlooked in the rush to find a solution. Let's talk about why understanding the problem matters. When you understand the problem, you can identify its root cause and not just its symptoms. This helps you to avoid temporary fixes that don't address the underlying issue. A clear understanding of the problem also helps you to avoid unnecessary complexity in your solution. By focusing on the real issue, you can create a simple, elegant solution instead of a complex one that merely dances around the problem. So how do you go about clearly defining the problem? Start by asking yourself some key questions. What exactly is the issue? What are the symptoms? What events or actions lead to the problem? What are the expected and actual outcomes? By answering these questions, you can get a clear picture of what you're dealing with. After you've answered these questions, write a problem statement. This is a concise description of the issue that needs to be addressed. It helps to keep you focused and to communicate the problem to others. A good problem statement should be clear, concise, and free from jargon. It should describe the problem, not the solution. Remember, the benefits of defining the problem are numerous. It helps to avoid unnecessary work, it prevents the implementation of incorrect solutions, and it assists in the creation of straightforward, effective solutions. Most importantly, it gives you a clear target to aim for. In the world of programming, a well-defined problem is like a roadmap to the solution. It shows you where you are, where you need to go, and what obstacles you might encounter along the way. So don't be in a rush to dive into solving the problem. Take your time to understand it first. Once the problem is clearly defined, you're halfway to the solution. After identifying the problem, the next step is to break it down into smaller, manageable parts. Now you might be wondering, why do we do this? Well, it's simple. Think of it as trying to eat an entire pizza by yourself. If you try to devour it all at once, you're likely to get overwhelmed. But if you slice it up and tackle it piece by piece, it becomes much more manageable. In programming, a big, complicated problem can feel like that whole pizza. It's complex, intimidating, and you might not know where to start. Decomposing or breaking down the problem into smaller sub-problems is like slicing that pizza. It makes the problem more manageable and less intimidating. Let's think about a programmer who's been tasked with developing an online shopping website. Now, that's a big project. But if they break it down into smaller parts, like designing the user interface, setting up the product database, developing the shopping cart functionality, it becomes less daunting. Each of these smaller tasks is a piece of the larger problem. By focusing on these smaller tasks one at a time, our programmer can give each aspect the attention it needs. They can solve each sub-problem individually, testing and refining as they go. This approach allows for more precise problem solving and reduces the risk of errors. Plus, it's a lot less overwhelming than trying to tackle the whole problem at once. Another benefit of breaking down the problem is that it makes it easier to delegate tasks in a team setting. Different team members can take responsibility for different parts of the problem, allowing for more efficient problem solving. So, when you're faced with a big, complicated problem in programming, remember to break it down. Slice it up like a pizza and tackle each piece one at a time. This approach will make your problem-solving process more manageable, more precise, and less stressful. Breaking down a problem makes it less overwhelming and easier to tackle. And that's the magic of decomposition in problem solving. So go ahead, give it a try, and see how it can enhance your programming skills. Choosing the right tools is like picking the right weapons for a battle. Indeed, in the realm of problem solving for programming, the tools you choose can make or break your success. How so? Let's think about it. If you were tasked to dig a hole, would you reach for a spoon or a shovel? Each tool is designed with a specific purpose in mind, and the same applies to programming languages and software tools. They each have their strengths and weaknesses, and understanding these can help you choose the right one for your specific problem. Imagine you're working on a web development project. Here, you might want to consider tools like HTML, CSS, and JavaScript. These languages are specifically designed for creating web pages and are widely supported across all browsers. On the other hand, if you're working on a data analysis project, Python might be your best friend. Its simplicity and the vast array of libraries available, like Pandas and NumPy, make it a popular choice for such tasks. But it's not just about the programming languages. Software tools also play a vital role in problem solving. Integrated development environments, or IDEs, for instance, can help streamline your coding process. They offer features like code completion, syntax highlighting, and debugging tools. Some popular IDEs include Visual Studio Code, PyCharm, and Eclipse. Another important tool in your arsenal should be version control systems, like Git. These allow you to manage and track changes to your code, making collaboration and troubleshooting much easier. To sum up, selecting the right tools is a crucial step in problem solving for programming. It's about understanding the nature of the problem at hand and matching it with the tools best suited to tackle it. It's about knowing the strengths and weaknesses of different programming languages and software tools and using them to your advantage. So remember, just like you wouldn't use a spoon to dig a hole, you wouldn't use a tool not suited for your programming problem. The right tools can make the process of solving a problem much smoother and more efficient. With the problem broken down and the right tools in hand, it's time to implement the solution. This is where the real magic happens, where your understanding of the problem and your chosen tools come together to create a solution. Implementing a solution in programming isn't just about writing code, there's more to it. It's a three-part process: writing the code, testing it, and debugging. Let's delve into each one a little bit more. Writing the code is the first step. This is where you use your chosen programming language and tools to write a program that solves the identified problem. It's like crafting a story. You're the author, and the code is your narrative. You're weaving together lines of code to tell a story that ends with a solved problem. Next comes testing. Once your code is written, it's crucial to test it to ensure it works as expected. This is where you run your program with different inputs to see if it produces the right outputs. It's like proofreading your story, checking for errors, making sure everything makes sense, and that the story unfolds in the way you intended. Finally, we have debugging. This is the process of identifying and fixing errors or bugs in your code. No matter how experienced you are, it's inevitable to encounter bugs in your code. Debugging is like editing your story. You're looking for plot holes, inconsistencies, or areas that don't work, and then fixing them. Each step in this process is important. Writing the code creates the solution, testing validates it, and debugging refines it. Each step builds on the previous one, bringing you closer to a robust and effective solution. Remember, programming isn't just about getting the right answer. It's about creating a solution that's efficient, effective, and elegant. It's about crafting a story that not only solves the problem, but does so in a way that's clear, understandable, and maintainable. Implementing the solution is the final step in the problem-solving process, but remember, it's as much about the journey as it is about the destination. Happy coding! Let's recap what we've learned about problem-solving in programming. Our journey began with the first step of identifying the problem. Remember, you can't solve a problem if you don't know what it is. So, always start by asking the right questions and understanding the issue at hand. Next, we moved on to breaking down the problem. Splitting a complex problem into smaller, manageable parts can make a daunting task seem much more approachable. After all, the best way to eat an elephant is one bite at a time. Then we explored the importance of choosing the right tools, Just like a carpenter wouldn't use a hammer to cut wood, the right programming tools can make your job a lot easier. Finally, we dove into implementing the solution. This is where you put all your planning into action and create something amazing. Remember, every problem is an opportunity to learn and grow as a programmer. Happy coding!